So right now, this is the part 2 of our notes for today. This is properties of logs. All right, what we're going to be doing is expanding condensing logs. Okay, so this is the rules for logs, expanding condensing. It looks like this. So if you are having two logs of the same base and they're being added together, you can combine the logs together and multiply the of parts, the x and the y. If you're subtracting two logs with the same bases, you're going to divide the x's and the y's, or whatever is in front of those two logs. And then finally, if you have an of part with an exponent in it, that exponent becomes a coefficient in front of the log. We're going to show you how to do all these problems and have some time also for you to try some on your own. Then what we're going to do at the very end of this video is have a thing where you can combine the two things we're doing today, which is properties of logs and then solving logarithmic equations from exponentials. Okay, so we'll see how that all works. All right, first question we got is we're doing some condensing. So we have two logs with a base of a, and they're being added together, and there's 2 and 10. So because they're being added together, we're going to multiply the 2 and the 10 together. All right, so now we have just one log base of a, and 2 times 10 is equal to 20. And this is our answer. We've just combined or condensed two different logs together to make one log. So we have log base a of 20. Okay. Next, we have natural logs of z plus natural log of t minus natural log of b. So we're going to combine all those natural logs together into one. For the z plus t, we're going to be multiplying. And then when we're subtracting log of b, we're going to be dividing that number, in this case b, from z and t. Okay, and now we can combine everything and simplify it out so it makes it look nice and pretty. So we have natural log of z times t divided by b. And there's our answer. Okay. Next, we have 2 log base 3 of r plus 6 log base 3 of n. Now in this case, we have these coefficients in front of both logs. We have a 2 and a 6. Okay, what we're going to do with those coefficients is they're going to be transported over to become exponents on their respective variables, the r and the n. So we have log base 3 of r squared plus log base 3 of n to the 6th. Now what we're going to do is next is condense them because they're both being added with the same log base of log base of 3 and r squared times n squared, or n to the 6th. We can simplify that out so it looks just like log base 3 of r squared times n to the 6th. And there's our answer. Okay, so we've seen 3 different examples of condensing. All right, there's number 4 and number 5 on your note sheet. Please try those out. So pause the video, try them out, see you do, and then come back. So hopefully you've tried numbers 4 and 5 out, and you're back for more. And here we go. So we have 5 natural log of x minus 4 natural log of y. So the 5 and 4 are both coefficients in front of the natural logs, and they're both going to become exponents on their respective variables. Now we have x to the 5th and y to the 4th. Because we're subtracting, we're going to divide x to the 5th and y to the 4th. So we have natural log of x to the 5th, y to the 4th. And that's our answer. Okay. Now we're going to condense all these into one logarithm. Okay, so we have the 3, the 6, and the 3 all become exponents on their respective variables. So we have a to the 3rd, b to the 6th, c to the 3rd. For a to the 3rd and b to the 6th, those are being added. So we're going to multiply those two things together, and the c to the 3rd is being subtracted, so that's going to be divided. So you'll end up with this. Log base 6 of a to the 3rd, b to the 6th divided by c to the 3rd. Okay. Next, we're going to look at expanding. We're going to be expanding logarithms. So we're going to look at 3 examples, then have you try 2 on your own. Okay, so here's the first one. So now, to see what we're doing here is you've got to see what's happening next to log base 3. It's 7 times x. Because you're multiplying 7 times x, that means you're going to be, when you expand it, you're going to be adding 2 separate logs together with 7 and x as their ofs. Okay, and there's your answer. All right, pretty straightforward. Next, we got log base 5 of 3 times a to the 3rd. Now there's a couple things happening in this. First of all, there's 3 times a to the third. Because we're multiplying 3 and a to the third together, we're going to have a 2 separate logs that are being added together. All right, the other thing that's happening here is we have a to the third. So that exponent on the a value has to become a coefficient. So that 3 is going to go back in front of the log and then become a coefficient in front of log base 5. So we have log base 5 of 3 plus 3 log base 5 of a. And that's your answer. Okay, so if you have a log problem and you're supposed to expand it and you have an exponent in that log problem, that exponent has to become a coefficient. All right, last example. We have natural log of x over y squared. Okay, because you're dividing x and y squared, they're going to be subtracted. Okay, and then that 2 is going to become a coefficient in front of the natural log of y. So you have this. All right, so we've seen 3 examples. Take a moment, pause the video, try 9 and 10 on your note sheet. All right, and then come back and see how you did. All right, so hopefully you're back. I'm going to expand these as much as possible. So we have log of 3 times x times y. Because we have 3x and y, they're all being multiplied together. So we're going to break it up into 3 separate logs. All right, and then you're done. There's nothing else to do. Okay, there's no coefficients to make because there's no exponents on any of the variables or the 3. Okay. The next one, we have natural log of 5s over 3r. All right, we're going to do this by actually splitting it up a little bit. We have 5 times s, that's 2 separate logs, and 3 times r, that's 2 separate logs, but the 5s is being divided by the 3r, so we're going to split them up. So we have natural log of 5 plus natural log of s. We're going to subtract that from natural log of 3 minus or plus natural log of r. Okay. And there you go. That's your answer. That's going to be your answer. That's a little more complicated. The ones on the test probably won't be that much involved. All right. So now we're almost done. We got one more thing to look at, and that is combining our properties of logarithms with condensing and expanding, and also making logarithmic equations into exponential functions. So that's what we have here. Now we have a condensing problem because we have log base x of 16 plus log base x of 4 equals 2. So what we're going to do is we're going to condense the logs together. So we have log base x, I'll get it. And then because we have 16 and it's plus 4, we're going to multiply those 2 numbers together. All right, and that gives us 64. Now, if we do what we did at the beginning or on the first video for introduction to logs, we're going to smash the log. The x becomes the base for the exponent of 2, and that equals 64. Now, if you solve this, you're going to square root both sides. So the square root of 64 is going to be x equals 8 and negative 8. Okay, but with logs, you can't have a negative number, so it's just going to be x is equal to 8. All right, next one. So now we're subtracting 2 different logs of the same base. So when we do that, we're going to have log base of 3 is equal to, because we're subtracting, it's going to be x divided by 4. All right, so we smash the log, and it becomes a base of 3, but the exponent of 2 is equal to x over 4. All right. When we do this problem, now it's not as hard as it seems. You're just squaring the 3, which gives you 9. And then you're multiplying both sides of the equation by 4 to get x by itself. So x will equal 36. Okay, so these last 2 equations have been problems where we're condensing. We're condensing logarithms. And then once we condense it to one big logarithm, we can then change the logarithm to an exponential equation and then solve that exponential equation for our x value. All right, now we're done with this. Please do the practice, work on these problems, and see how well you do. Ask questions the next time we have Zoom. Make sure you know what you're doing.